experiment. One of the most intriguing findings in recent years has been related to the behavior of muons, heavier cousins of electrons. The muon G2 experiment, which is conducted in collaboration with CERN, has measured the magnetic moment of muons with unprecedented precision. Interestingly, these measurements show a discrepancy from the values predicted by the standard model. Cox delves into the significance of this discrepancy, explaining that it could be an indication of new physics. If confirmed, it might suggest the existence of previously unknown particles or forces. The muon G2 results have generated considerable excitement, as they may point toward a breakthrough in our understanding of particle interactions. While caution is warranted, since anomalies like these could sometimes be statistical fluctuations, the ongoing investigation into muons remains one of the most promising avenues for discovering new physics. New insights into quark-gluon plasma. Another unexpected discovery that Cox discusses involves the study of quark-gluon plasma, a state of matter that existed in the early universe, just microseconds after the Big Bang. At that time, quarks and gluons, which make up protons and neutrons, were not bound together in the familiar structures we see today. By using the LHC to collide heavy ions at extremely high energies, scientists have been able to recreate and study quark-gluon plasma. Recent experiments have revealed surprising details about the behavior of this plasma, including its viscosity and flow patterns. These findings could help physicists better understand the conditions of the early universe and the processes that led to the formation of the first atomic nuclei. Cox explains that while quark-gluon plasma was once thought to be a simple, nearly frictionless liquid, recent data suggest it behaves more like a complex fluid with interesting and unexpected properties. This new understanding of quark-gluon plasma is helping physicists refine their models of the early universe. The future of particle physics. As Brian Cox reflects on these and other discoveries from CERN, he emphasizes the importance of continuing to push the boundaries of knowledge. While the standard model has been remarkably successful in explaining the behavior of known particles, it is clear that there is much more to learn. The mysteries of dark matter, dark energy, and the potential for new physics beyond the standard model provide a rich field for exploration. Looking to the future, Cox believes that the next generation of particle accelerators and detectors will play a crucial role in unraveling these mysteries. CERN is already planning upgrades to the LHC, as well as developing new technologies for even more powerful particle accelerators. These advancements will allow researchers to probe deeper into the subatomic world and potentially discover new particles and forces. In addition to technological advances, international collaboration will remain key to the future of particle physics. CERN's success has always been built on the collaboration of scientists from around the world, and Cox stresses the importance of continuing this tradition. By working together, physicists can tackle the most fundamental questions about the universe and perhaps one day answer the question of what lies beyond the known laws of physics. The discoveries coming from CERN are reshaping the landscape of particle physics, and as Brian Cox highlights, they are as exciting as they are unexpected. From potential insights into dark matter and supersymmetry to the strange behavior of muons and the new understanding of quark-gluon plasma, CERN continues to push the boundaries of what we know about the universe. While much remains to be uncovered, the future of particle physics looks bright, and the work at CERN will undoubtedly continue to inspire scientists and curious minds alike. In recent years, the world of particle physics has witnessed groundbreaking advancements, largely driven by the research at the European Organization for Nuclear Research, CERN. Known for housing the largest particle accelerator in the world, the Large Hadron Collider, LHC. CERN has been at the forefront of scientific exploration into the fundamental building blocks of the universe. In 2024, Brian Cox, a renowned physicist and science communicator, discussed the latest unexpected discoveries from CERN, emphasizing their potential to reshape our understanding of physics. A brief background on CERN. Founded in 1954, CERN has long been a central hub for physicists from across the globe. Its primary mission is to study the fundamental constituents of matter and the forces that govern them. The LHC, which began operation in 2008, has allowed researchers to recreate conditions similar to those of the Big Bang, offering unparalleled insights into the very fabric of the universe. The most famous discovery from CERN to date is the Higgs boson, sometimes referred to as the God particle. Discovered in 2012, this particle provides the missing piece of the standard model of particle physics by explaining how other particles acquire mass. However, as Brian Cox notes, the journey did not end with the Higgs boson. Instead, this monumental discovery opened up more questions than it answered, setting the stage for further groundbreaking research. Unexpected discoveries from CERN. As Brian Cox discusses the latest findings from CERN, he highlights several unexpected discoveries that are pushing the boundaries of our current understanding of physics. Some of these discoveries are puzzling and may require the development of new theories beyond the standard model, while others have opened new avenues of exploration. One of the major ongoing mysteries in modern physics is the nature of dark matter and dark energy. These two invisible forces make up about 95% of the universe's total mass-energy content. Despite their dominance, physicists have yet to detect dark matter directly, although they observe its gravitational effects on galaxies and other large cosmic structures. Recent experiments at CERN have provided intriguing clues about the potential identity of dark matter. Cox highlights the discovery of anomalies in the behavior of particles that may point toward new, undiscovered particles that could be connected to dark matter. For instance, researchers have observed unexpected results in certain particle decay processes, raising the possibility of new physics beyond the standard model. Brian Cox explains that although these results are far from conclusive, they represent an exciting avenue for future research. If CERN is able to identify the particle or particles responsible for dark matter, it would be a monumental breakthrough in both particle physics and cosmology. Hints of supersymmetry. Supersymmetry, or SUSY, is one of the leading theories that physicists have been exploring as a potential extension of the standard model. The theory posits that every known particle has a corresponding superpartner particle, which could help solve some of the unanswered questions in physics, including the nature of dark matter. Although no supersymmetric particles have been definitively detected, Cox discusses tantalizing hints from recent experiments at the LHC. These hints suggest that researchers may be on the verge of discovering new particles that could fit into the SUSY framework. Such a discovery would not only provide answers to questions about dark matter, but also help unify the forces of nature in a more comprehensive theory. However, as Cox points out, these results are still preliminary, and more data will be needed to confirm whether SUSY is a valid theory.